All right, so I want to show you today how do we do percent composition given a formula. This is a really important skill to have in our toolkit because analytical chemists and forensic scientists can identify a substance just on the basis of the percentage composition. So let me show you how we do that. Let's start with a substance like Fe2O3. So if I start with just the formula, all I do is I just go through a series of steps and make a table. I'll take the elements and write them down. Iron and oxygen, and then what I do is write down the number of each one that I have present in the compound or unit formula. So here I have 2 irons and 3 oxygens. Now for each one I use the periodic table and then multiply it by the molar mass of that substance. So for iron I say times 55.8, and then for oxygen I'll use 16.0. Now, when I do that math, I come up with 111.6, and then for oxygen 1632, we get 48, and then we just add those together, and I get 159.6 grams per mole. Now that is the molar mass for Fe2O3, and we can call that then the formula weight. So some people you'll see write, well, FW, formula weight, is 159.6 grams per mole. To get the percentage composition, all we do is we take the part divided by the whole times 100, just as you would for any percent. So we have 111.6 over 159.6, so we use this number over the whole, so part over the whole times 100. And when we do that math, we end up with 69.9% iron in Fe2O3. By the same token, we do the same thing for the oxygen. I take 48.0 divided by the whole, which is 159.6 times 100, and we end up with 30.1% oxygen. When we do that, we now know that this substance is almost 70% iron and 30% oxygen. We should check it just to be sure that our percentages add up to 100. They should sum to 100, and we know we've done our calculation correctly. So if we find a substance that is 70% iron and 30% oxygen, we know reasonably that it could be Fe2O3. All right, that's how we do percentage composition. Let's get some practice at it, and I'll see you soon.